You know, Alex, people see these glossy photos of 3D prints online and they think the machine just spits out perfection, like it's a Star Trek replicator that hums for a second and then hands you a finished product and a cup of Earl Grey.
Is that not how it works? Because I'm looking at you right now, and you look like a Victorian clockmaker performing surgery on a plastic porcupine.
That's the reality they don't show you in the highlights. This porcupine is actually a manifold for a custom intake. And right now, these support structures are holding on to the main body like a nervous toddler on the first day of school. If I'm not careful with these pliers, I'm going to snap a mounting tab, and then I'm just looking at 20 hours of print time turned into an expensive paperweight.
See, this is why I like the finished stuff. But seriously, why is post-processing the part everyone skips over in the tutorials? You spend all this time on CAD, you obsess over level beds and nozzle temps, and then the piece comes off the plate looking like it grew hair.
Because post-processing is where the hobbyist and the professional part ways. It's the unfun part. It's messy, it's tedious, and it's where you can ruin all your hard work in about 5 seconds of impatience. But if you want a part that actually functions, something that doesn't just look like a 3D print, but looks like a manufactured component, you have to embrace the grime. Take this manifold. It's FDM, fused deposition modeling, so it's built layer by layer. Those layers are like the rings on a tree, except they're tiny speed bumps for air or mechanical parts. If I just bolt this on, the surface friction is going to be a nightmare. Post-processing isn't just about making it pretty, it's about making it work.
Okay, so walk me through the surgical phase then. You're currently attacking that thing with a dental pick. Is that really the professional way?
It's the first line of defense. Support removal. It's mandatory, but it's the most basic step. You've got two flavors here, standard and dissolvable. What I'm doing now is the standard manual labor. Needle nose pliers, picks, and a lot of swearing under my breath.
And the risk is, what, gouging the actual part?
Exactly. If the supports are too dense, they leave these white stress marks or little pock marks where they were attached. It's like pulling a stubborn weed and taking half the lawn with it.
There's a mental image. So what about the fancy stuff, the stuff that just disappears?
The set it and forget it method. Dissolvable supports. You print your part in one material, say PLA, and the supports in something like PVA or HIPS. Then you just drop the whole thing into a bath.
Like a bath bomb for engineering?
Pretty much. PVA dissolves in plain old water. HIPS needs a solvent called limonene, which smells like a citrus explosion. It's great for complex geometries, internal channels where you couldn't get a pair of pliers if your life depended on it. But you move into a different set of problems there. If you leave it in too long or the water's too hot, you can actually warp the main part. It's a delicate balance.
So, once the hairs are gone, we're still left with those ridges, the tree rings as you called them. How do we get from ribbed for no one's pleasure to that smooth finish I'm holding?
Now we're talking about my favorite kind of torture, sanding. If you want a professional finish, you have to be willing to lose your fingerprints. I start with a coarse grit, maybe a 150 or 220 just to knock down the mountains. But here's the secret. You have to wet sand. If you sand dry, the friction generates heat, and heat turns plastic into a gummy melted mess. It's like trying to sand a stick of butter.
I've seen you out here for hours. Is there really no shortcut? No magic smooth button?
There is, but it's more like a hazardous vapor button. For ABS plastic, you can use acetone vapor smoothing. You basically suspend the part in a chamber with acetone fumes, and it melts the outer skin of the plastic just enough to liquefy the layer lines and fuse them together. When it works, it looks like it was injection molded. It's beautiful.
When it works, I hear a tragedy coming.
I once tried to build a DIY vapor chamber out of a rice cooker and some questionable YouTube advice. I put a part in, got distracted by a phone call, and when I came back, I didn't have a decorative helmet anymore. I had a very shiny, very expensive puddle of gray goo, and the smell. My shop smelled like a nail salon in a forest fire for 3 weeks.
So, precision is key. Who would have thought?
And then there's the powder side of the house, SLS and MJF. These don't use supports because the powder bed holds the part up while it's being printed.
That sounds way easier. No pliers, no weeding the plastic.
True, but instead of pliers, you get a sandbox. When the print is done, you're basically an archaeologist digging for treasure in a bin of nylon powder. This is where tools like the fuse sift or the fuse blast come in. You're using air pressure and media blasting to get that excess powder off.
Media blasting. Is that just a fancy way of saying you're hitting it with tiny rocks?
Precisely. Glass beads, ceramic media, or even walnut shells. It's like a power washer, but for tiny details. It gives the part a uniform, matte finish. If you want it even smoother, you throw it in a vibratory tumbler. It's a big tub of abrasive triangles that shakes the part for 6 hours. It's basically a spa day for your hardware.
It sounds like a lot of equipment just to make something look normal. What's the ROI on all this shaking and blasting?
It's about more than the look. Take a look at this. You can electroplate these things. You can take a plastic print, coat it in a conductive paint, and then plate it with nickel or copper. Suddenly, your toy part has the surface hardness and thermal conductivity of metal. Or you can do resin infiltration, where you soak a porous part in cyanoacrylate, superglue, to fill in the microscopic voids. It can double the strength of the part.
Okay, so it's not just vanity. You're actually changing the mechanical properties. You're making the part pro from the inside out.
Exactly. A professional result isn't just about surviving a 20-point inspection. It's about ensuring the part doesn't fail under load or that it meets ISO standards for surface texture. In industries like aerospace or medical, if your surface roughness is off by a few microns, that part is scrap.
So, for the guy in his garage, not the guy making heart valves, but the guy making, say, a custom car dash, what's the one thing he shouldn't skimp on?
Patience and a good primer. Everyone wants to jump straight to the color, but the magic happens in the gap filling. You use a high build primer or even an epoxy coating like XTC 3D. It fills the valleys so you don't have to sand the peaks down to nothing. It's the difference between a paint job that looks like it belongs on a Ferrari and one that looks like it was done with a Sharpie and a prayer.
A Sharpie and a prayer. I think I've seen that build on Reddit.
We've all been there. My first pro project was a replica of an old camera housing. I thought I could just spray paint right over the layer lines. I put on about 8 coats of paint, thinking it would fill in. All I ended up with was a very thick, very lumpy camera that never quite dried. It felt like a gummy bear for 6 months. I eventually had to toss it and start over.
So the lesson is, don't try to hide the mistakes with paint.
Exactly. Fix the surface first. The post-processing is the foundation. If the foundation is shaky, the whole house is going to tilt.
It sounds like post-processing is really about respect. Respecting the work you did to design the part and respecting the material enough to see it through to the end.
That's a good way to put it. You're taking something that the machine made and you're turning it into something that you made. The printer does the heavy lifting, but the craftsman provides the soul. It's that final 10% of the work that provides 90% of the value.
I think I'm going to go home and sand that lumpy coaster I made last week.
Bring a bucket of water and some 400 grit. Your knuckles will thank me later.
No promises on the fingerprints, though.
No one needs all 10 anyway.
Fair point. So what's the big takeaway for our listeners today, Tiger?
Don't look at post-processing as a chore you have to get through before the project is done. Look at it as the actual manufacturing phase. Whether you're snaring supports with a pair of pliers or tumbling a nylon gear in a bed of ceramic, that's where the quality happens. A 3D printer gives you a shape. Post-processing gives you a tool.
Well said. Just maybe stay away from the rice cooker acetone baths for a while.
Yeah, the insurance company was pretty clear about that last time.